computer. We are recording. Share the screen. All right, screen is shared. And my office chair has decided that on random, it's just gonna like let out some air. So I'll slowly kind of squeeze down. I don't know that I need my video on, but anyways, awesome. I hope that you guys are having, getting some value again out of the course that we're doing this week. Kind of go back over stuff. So yesterday we built 2 different websites on a Raspberry Pi, one with a LAMP stack and one using Flash and Python. So I thought those were, first of all, they worked, right? So that's always a good thing. The second thing is I thought they were really fun. I had a good time. And then we did start to find, I mean, I think we got those 2 labs get you to a certain point, and then I think it could easily, like for those that teach web development, I think you could easily take that and just continue on, teaching all the things that you want to teach in a web development program on the Raspberry Pi. So pretty cool. So this is our drive, right? So we've got the web link still, right? And if you want to add any comments to the the status of the IoT fundamentals course that's going to be pushed up to Cisco. You can do that on this document here that I've got pointed at there. And then yesterday we did add the Pico digital, the book that we're going to use today was added there. So if you want to download the PDF, that if you haven't got to it from somewhere else, please do that. Second item is like, our page here is now we're up to 6 pages of links. So like I said, I'm going to give you, months and months worth of work. I've added everything that I'm going to talk about this morning already. So it's all here and ready to go. AdGuard's still functioning. I think that's totally cool. We did that on the second day of the class. So that's working. In the YouTube channel, I've added day 3 morning and afternoon. I recorded them properly. So again, these are unedited. I just copied them and put them up there. So you get all the ums and the pauses and the weirdness. So that's just how it is. For today's list, or for today's class, right? And most of you already know this, but so summer, right? So from my IT instructor, WotC summer CIS topics is going to get you here. And the reason I want to do this is that link to the book is here. That'll automatically download the book as well if you haven't already got it from our drive. And then the kits, right? And these are not, so it's too late to buy the kit, obviously, but what I wanted to do is look at the parts. So if you don't have a kit, but you have parts around, then, all these things are completely doable. So, right, the Raspberry Pi with the male headers, right? So that's going to be the Raspberry Pi that has the headers already soldered on, solderless breadboard. We got jumper wires, right? And they've got a variety, right? So, and I always recommend a variety. In fact, I have my students, if we go back over here, I have my students buy, jumper wire. So I have them do something like this, like spend $6 and get 40 of each of the flavors. So that's something to think about. Resistors, right? So we're using 330 ohm resistors, a buzzer. Then there are some 10K potentiometer resistors. So any Arduino kit that you buy will typically come with 330s and 10Ks. Right? 330s for sure, and then 10Ks are a usual component, especially if you do if it has a temperature sensor in it, I believe it's going to have the 10K resistor. There's a PIR sensor. So, we have a PIR sensor thing. And then the LCD module, the module that they have here is a 4-pin module. I think there's a picture of it later up above, but I had to go search and do my stuff to find one that was 4 pins. I have some that have like 20 pins, and I have one that has 3 pins. And I was like, oh crud, I'm not going to be able to do this. But then I found one. So the 1602 LCD module, it's got the 4 pins with ground, VCC, SDA, and SCL. If you have that, you're great. If you bought one of these kits and it has something different, the kit actually has instructions on how to wire it for that particular project. So the LED strip, I don't have an LED strip, but if you have one, great. That's in the appendix. So I don't know if we'll get that far. I won't be able to do that one. The spare header, I think the spare header is actually allows you to pin these things, these 3 items down here, which I don't think we're going to use. And then a USB cable with a switch button. That's gonna, this particular kit, so you can connect your device to your Raspberry Pi, and then a box. So this one just I mean, it's a basic kit, but it was designed to work with this book. So here's what the parts look like: buttons, LEDs. This one has potentiometers, right? So potentiometers, there's the PIR sensor, the buzzer, there's the LCD panel, and then you can see the little LED strip there. That I wanted to find one, but then there's all the varieties and how they went together. I wasn't sure. So I don't have this particular kit, but I've got all the pieces and parts minus that one part. I do want to point out, here's that LCD panel. As long as you have an LCD panel that's lit up like, or that's wired like this, you'll be in good shape. We'll be able to do something like this a little bit later on. So that's the kit. I mean, that's one of the kits, but the idea of having those parts is if you have an Arduino already, if you already have the SparkFun kit, you have like 90% of those parts already kind of lying around. So it shouldn't be too big of a deal to get that. If you don't have that stuff, or you don't have the Pico, right, obviously hang out with us and watch as we go through this today. I did find a couple of interesting articles. So the 8 top Internet of Things certifications. So there's this Internet of Things Foundation certification. It's pretty hefty certification. It's pretty expensive too, $349. But one of the things, right, that as a particular, not really a topic, but like this, if you start to have a lot of certifications in it, and there's a need and a demand for it. Over time, right? So I think this is kind of the big one. This IOTF one is kind of the big overriding certification in this field. I'm not sure of CertNexus, but they've got a couple, right? They got a practitioner, security practitioner. This one interested me, the Microsoft Certified Azure IoT Developer. So as we have a cloud, our sysadmin degree is now a cloud sysadmin degree. And we have a lot of stuff that we do on AWS, but we also teach Microsoft Server, and we're trying to integrate Azure type components into that. So I think it would be fun to possibly maybe do some Azure IoT in the Connecting Things course to kind of start tying all of those things together, right? So introducing them to these cloud-based solutions, even from an IoT perspective. And then also there's the AWS has an Internet of Things Foundation series. That doesn't look like it's a certification, but it looks like it is an online course to kind of teach you things. Even Stanford now has an Internet of Things graduate certificate. So I point these out because I really think, right, that IoT, is gaining momentum. I mean, there's, from a consumer standpoint, every single, anybody that's connected to the internet has some sort of an IoT device in and around them. As smart homes become more prevalent, as smart cars become more prevalent, as right, those kind of things are going to continue, right, as we start adding intelligence into those. So at some point, as a system administrator, as an IT professional, you're going to have to deal with IoT devices in your environment, either in a business environment, home environment, whatever the case may be. So I think, just understanding that, and is why one of the reasons why, right, it makes some sense to have something like this in a degree plan, or as an option for as an extra class, or as an elective, things like that. So I don't think I shared this one onto our page yet. So we'll throw that one over there. I'm going to leave it here for now, but I'll throw it over there a little bit later. The other thing that I saw this morning that was really interesting is, right, because there was the comments or the conversation we had a couple of days ago about Raspberry Pi kind of pushing a lot of their chip and sales to the industry side of things. And then I saw this article this morning and I'm like, oh my gosh, like Arduino just got $32 million in funding to develop enterprise IoT. And like Arduino has always been kind of a DIY kind of a deal, not a commercial deal. And this kind of changes that focus, right? So even Arduino, which has been around forever, you know, it existed before the Raspberry came about. It's now like looking at IoT as a, you know, as a possible, I don't know if it's revenue stream that they're important about, or it's just the fact that they want to have their, you know, have that gear. So then that becomes now, Arduino becomes now, you know, a training topic in the IoT world as well. So even though we already use the Arduinos, right, it's just, this kind of helps to show that it's not just, you know, the manufacturing devices, those real specific devices that are out there now that, you know, our Raspberry Pis and Arduinos are now making their way into the industrial side of the they're just making their way into industry, right? So it's no longer that they're DIY, you know, quote unquote toys, right? Because a lot of people give them, you know, kind of look down on those two products as being more maker related, not commercial related. And that's no longer the case with either one of them. With the compute modules on the Raspberry Pi side, and now with Arduino, with this kind of investment into the company, I don't know. I think it's an interesting thing to think about, right? That both, you know, we now have, you know, there's certifications around IoT now, and then two of the biggest players in the maker circuit board, you know, small business, you know, small or single board computer market are both kind of focusing on industry. Okay. So yeah, some things I wanted to share there. And then the last thing I want to share that I came across the desk this morning, which you may not care, you may care, I don't know. But Pi Wars, right, which is the robotics competition that my team has been involved with for the past 5 years. They are actually looking to see if people are interested in doing an in-person competition next year. So I'll share that with you if you are interested in that. You go out to their website and check out all the cool stuff that we do. But it's a Raspberry Pi based robotics competition. It's a 2-day competition. The first day is for elementary school level, and then the second day is for they call, you know, professional or adults, right? So my team, as a community college team, we compete usually in the intermediate level. There's a beginner, intermediate, and professional level, and we're competing against, you know, computer scientists, folks that work in the industry that build robots and things on a daily basis, and we compete with those folks on the second day. So my team goes and we actually volunteer the first day and we compete the second day, but it's a single day event where you have to do 7 different, usually 6 or 7 different competitions on this with the same robot. You're allowed to change parts and pieces, but it's for us, it's a global experience, right? Which is was at the time when we started this, one of the pushing factors for the school, for they wanted students to have an experience, a global type of an experience. But I actually take a team there, and we go to Cambridge for the events. We spend a couple days in London, and then we spend a day at Bletchley Park, learning about the bomb machines that Turing and his team built, and learning about Colossus, which is one of the very first tube computers, tube-based computers that was built specifically to break encryption. And we get to see those things and tour the Computer History Museum and things like that. So if you're interested in putting a team together, more than happy to help you figure out how to do that. We have a student group here, a student organization where that's kind of how we do our fundraising. So we can fundraise through that group, and we beg, borrow, and steal as much as we can to get a group of students. Every time we've gone, we've taken 5 students, most of who have never been out of the States, and in fact, I've had some that had never been out of the state of New Mexico. We've taken them to England, So pretty cool. I just like to share those because it's a lot of fun. I get a kick out of it, and I do like going to England, so that's part of the deal. But yeah, so that's the cool stuff going on today. So some neat things that came across my desk this morning that I think are totally fun. All right, and no, we're not done with the web resources. So pinout.xyz. So this is probably the only Raspberry thing we'll talk about today. Raspberry Pi thing we'll talk about today, but this website, pinout.xyz, totally awesome website. You can see over here they've got a kind of interactive pin layout here, but what's neat about this is you can check out, they have a board explorer. So like these are a whole bunch of different boards that you can add to your Raspberry Pi. Right, totally fun stuff. Like, so for example, let's just grab this drum hat. So let's say you have a student that's doing the drum hat, right? So you click on the drum hat, it shows you over here, like when you plug this in, it shows you over here what pins are actually being used. So you can technically, and I've had students do this, they can actually wire from these pins to the pins on the board and not have to plug this into the board and then use other pins for other things like buttons and lights and other boards that don't have competing pin usage. So I think this is a pretty neat website for students to kind of figure out as they kind of looking to build out a project, right? How could we add, say, maybe 2 or 3 different boards that normally would plug in, right? Those hats that plug in, like, you know, can we put this Adafruit on there, right? It only needs these 2, right? So as long as and they're I2Cs, so you should be able to daisy chain those. But the idea is that we would know this. Now we know exactly what pins, 5 volts as well, and they use this ground button. But just, interesting. I think it's a great website for those kind of resources. So we'll put that on the board as well, from the standpoint of a resource that you can use to build. And this is maybe a third of all boards that are out there. It's a ton of boards. But yeah, that's pretty cool. And all these things do something different or similar, just in a different format. Good stuff. All right. And then Raspberry Pi documentation. So this is the microcontrollers documentation. We went into the MicroPython yesterday, but I did want to put the link, and I think I've already done the link for this one, but the link out there so you can get to the Pico documentation. And again, I'm not a programming instructor, but C++, there's an SDK that you can use, so you can do C and C++ programming on the Pico. We're going to use the MicroPython today as we play around with this, but I just want you to be aware of this. On this same page, if you click on computers, you should be able to get to like getting started with the Raspberry Pi OS. There's all of the things related to, here's the compute modules. Here's the information on tech specs for the the Pi hardware. Right, so all of that's there. And then any accessories that are Raspberry Pi accessories. So these are hats that were designed or built by Raspberry Pi, and then even tell you kind of how to build hats and things like that. So if you have students that are in in that circuit building kind of a program, right, they could actually design hats that would work on the Raspberry Pi. So pretty cool stuff. Again, that one's going to be in the list of documentation in our website page. And then I did want to I started looking for like things related to the Pico, and there's a lot of like getting started with the Pico, introduction to the Pico, things like that. So there's a ton of that. I'll highlight a couple here. The one from Tom's Hardware is really nice. Tutorials, pinouts, what you need to know. So it kind of explains what a Pico is. This is a Pico and this is a Raspberry Pi Zero. But it kind of goes through that and what the differences are. So that's a good article. And then Raspberry Pi does have, they have a tutorial like we've been going through the last couple of days, right, on the Pico. I'm not I didn't look to see if they're matching the book with this or not, but I think that would probably be something instead. If you didn't want to use the book and you wanted to use one of the online tutorials, this would probably be the way to do it, right? So pretty cool stuff there. And then Circuit Digest. So I was trying to find like, man, there's got to be other things other than just getting started with stuff. So this one does have, right, some getting started things, but here's like a, Bluetooth, how to use Bluetooth with the Pico, getting started with the C++. Here's interfacing an ESP8266, right, which I think that was a question or a comment that came early in the week. Controlling a servo motor, interfacing with LCD. There's lots of cool projects on this page. And then like this OLED, right, using an ultrasonic sensor, right? So just, so lots, I think this one was really cool. Lots of tutorials here for the Pico. Right, so the Pico being relatively new is not going to have a ton of them out there, but this one has, they have 10 here. That's pretty nice. I also found from DigiKey, again, this is more of a how to get started with the C++, right? Again, I'm not a programming instructor, but I know that I constantly see C and C++ in most curriculums. So I wanted to make sure that you guys, those that are programming instructors, that stuff existed, that it's available. This one here, How to Electronics. I think, yeah, they got some really fun projects here, right? So this is, right, we can do this one, right? A Pico web server. We don't have the ESP8266 with us, but you can create a web server with that right there. Right? So oscilloscope, that's kind of cool. Here's a temperature sensor, and they're using that little display there. Right? There's a primer kit. I don't know who does that one, but the LCD tutorial, right? And then we got this LCD, this temperature sensor, right? And they're using a different type of a display. There's a ton. Like this one, I think has there was like 20 or 30 different, right? So totally cool projects that are going to go beyond what we're doing today. But I think what's interesting is you can then, like, you can pick the ones that you like, right? That would maybe fit into what you're trying to have the students learn, and you can do Pico stuff, and you can actually then have them use the same gear on, in some of these cases, have the same gear on the Raspberry Pi, or then have this connected to the Raspberry Pi and sharing information with the Raspberry Pi. So again, I think I've saved all these on the web page link. And I know it's overwhelming. I just wanted to make sure that you saw these resources at the beginning of each day, and then we'll put them off to the side and you can then play with them as you feel fit. Make use of, I don't know if you guys are familiar with this web page, they do a lot of really cool stuff, but intruder detection, so Bop It, Minecraft controller, right? Create VGA video with a Raspberry Pi, Pico home automation, right? So we're getting into some home automation stuff that's pretty cool. For music, so MIDI controllers. So there, again, another set of really cool, fun projects. Right? These projects all probably require extra parts. Obviously we've got to find a Bop It. But the more of these things that you're aware of, the more you can kind of gear your projects. Or if you're going to have students build projects on their own, I like to provide these as lists of things that maybe inspire them to do things. Right. So the other day, and I think Katie, right, you use the quick stuff from Spark Fun. So this is an I2C, you can daisy chain things, you got all kinds of and they're showing the Arduino here, but there is a board that they make. I don't know why I didn't.
It's the FAT, P-H-A-T. You're looking for the Pi.
Yeah, well, there's a FAT, and there's also, yeah, the P hat, right? And then there's also right, so here's this is the RP 2040, which is the same silicon that's on the Pico, right? Built with a quick connector. This one has a quick connector as well. And then they should, like you said, there should be a P hat that you can add to the Raspberry Pi, right? That then you can use the same sensors. You can use the same quick sensors on the Raspberry Pi as well, through the connector, like this guy right here. So this little device. It extends your, it plugs in, and you can use these ports on top to continue to use the pins, but you also have these quick connects, which allow you to connect sensors to your Raspberry Pi as well. Actually, no, it looks like you flipped that. I flipped that over. This piece here allows you to plug it in to the Raspberry Pi. So they're not going to extend, but you're going to use the quick sensors anyway. I'm trying to see if there's not any other pictures that are, you can see right here, connect a little sensor to that. Okay. So if you want to use quick connect sensors, right, to minimize wiring, and right, and they all, I don't know, SparkFun makes quality product. I really like their stuff. Also, there's another, so Seed Studio and this Grove components. I have a Grove kit from an early Raspberry Pi thing, but they make right there. Let me actually jump over here. This actually, you plug the Pico in, and it has a real similar connection like the, so it's just a kind of a different infrastructure. So this is a Pico plugged in, and then you've got 8 of these little ports that you can plug sensors into. Right, costs $4.30. They have a kit, which is this web page here. I think this kit's $47, but it comes with, you can see all the different sensors. So these are Grove sensors, and I don't know if they use the same quick connect component or like connector or not. It looks like there's one extra pin on this one. I don't know. I'm not 100% sure. And I'm not advocating for either one. I just was aware of the Grove stuff because I do have a Raspberry Pi Grove kit that worked really well for us. So there's like 2 of these pre-wired solutions that you could, use. So those are both pretty cool. And this one is specifically for the Pico. SparkFun, they make a Pico version of, or a quick connect version of the RP2040. I didn't see that if they may come out at some point with a board like that Groove one that you can just plug your Pico into. And then from yesterday, this website, which is just how to set up your Pico with your Mac if you're going to program with your Mac. My plan today is to use a Raspberry Pi as the controller for the Pico. You can also, there was instructions as you go through this. There's instructions that drop you into doing the same. And we did it on Windows. Like if you watched yesterday afternoon's video, near the end of the day, we actually connected the Pico to my Windows machine here. And then this is the book we're going to use today. And that one doesn't matter. Awesome. All right. So those are the list of things, the resources. Again, I'll make sure that they all are in our document, right? So that you can kind of go back to those. The focus of today is basically to work through the Raspberry Pi Pico. Yesterday afternoon was the first time for me to plug in a Pico and do anything with it. We got the LED light to turn on. I already like the fact that if you connect it to a Raspberry Pi, Donnie automatically sees it. I don't have to think about it, right? That kind of environment where or the ecosystem where they all kind of work together. And then I do like the fact that we're using Python to program it. So then in my IoT class, everything is Python. Right? It's MicroPython. It's got a couple, it's using a little bit different libraries, but the concepts are all the same and the code is all the same, while true loops are all the same. All that kind of stuff is the same. And then you saw we started playing around with things and making modifications just to kind of see, does it relate? Is it similar? And it was, right? So I really like that idea of it. So the idea of today was for us to simply play with the Raspberry Pi Pico, right? I don't have my expectation is to have some fun with it and to learn about it, to see if it would possibly fit in as a replacement for, say, having an Arduino so that we have a more, more connected set of components in our kits. And right at $11, this board is significantly cheaper than an Uno, which is a $20 board by itself. So I think we can probably, again, can I reduce the cost down for the students to make that a doable solution, right? Speaking of that, so speaking of bringing costs down for students, the other thing that I want to test here this summer, and I got the technician to do this for me. Oops, I don't want to org. But we've had this in the past, but we're testing a dual boot solution in our lab. So my lab is different. So I know that everybody has different requirement or different restrictions within their environments. In my lab, first of all, we're in a sandbox, and all of the students are administrators on the computer. So I know that doesn't match probably 90% of everybody else's stuff. However, you can, right, not be administrator, but have dual boot capabilities, right? So we set up, we have a machine that's dual boots. It dual boots Windows, right? So it defaults to Windows. And then you can restart the machine and choose to boot into the Raspberry Pi desktop. So if you go to software here, and if you have an old laptop or an old PC, you may want to try this just on your own. But if you scroll down to here, right? So go down near the bottom, Raspberry Pi desktop for PC and Mac. This is an operating system that's designed to work on any x86 computer, right? So and one of the things, and I have it listed down, is we're going to test this in the VM environment as well, to see, or in the VMware environment, to see if we can run these on. I think we can. I think I've run it on a desktop in Hyper-V as well. So we can see, I'm pretty sure it's doable. But the reason that I say that is because if you can dual boot a computer and you have the Raspberry Pi desktop, then so all of the things that you can teach on a Raspberry Pi can be done on that desktop, right? So the web pages and things like that, which you could do in other places, but right, my thinking is that at the same time, though, the desktop, you can take I don't know where I set one, but the Raspberry Pi Zero, right? The way the desktop operating system is built, you can plug a Raspberry Pi Zero into the desktop computer with a USB cable. And if you're running the Raspberry Pi desktop, it will recognize that device and allow you to program the pins on the Raspberry Pi Zero, right? So now I can take, a Raspberry Pi Zero, which may, and if you buy it with pins on it, it's like a $15 device, right? So I can have the students buy a $15 Raspberry Pi Zero and a USB cable, and then they can plug it into the lab computer, right, in the classroom, and actually be able to do the physical computing components on their computer right there. The Raspberry Pi Zero, right, the desktop operating system is also a desktop operating system. So you can plug it into a monitor and, or remotely connect to it like you would a regular Raspberry Pi, and do the same kind of things we've been doing from here as well. So as long as, like, if they take it home, they can plug it into their network. Actually, it doesn't have a network cable, so they'd have to buy an extra component to plug it into their network. Now I'm kind of thinking through that, but they should be actually wireless. They should be able to do wireless. Yeah, it comes wireless, so you can connect it to the wireless network, connect to it remotely, do SSH, do VNC, which I really want my students to be completely comfortable with doing those things and have that be a normal operating procedure, because in the IT world, I tell you what, that saved me thousands of dollars of expenses being able to remotely connect to my clients' machines from the office and not have to drive to their locations every time we needed to fix something. So again, I think this idea, like I'm trying to get this kit to be as least expensive, as inexpensive as possible. That's what I'm trying to get to for the students, but be able to teach them all of the things that we can currently teach with the equipment that we currently use. And if I can
where's the dual boot come into play here?
What do you mean by dual? Where's it come into play? So in my lab, like, I want them to have access to the Windows desktop for the things that we need Windows desktop to do, and then I want them to be able to dual boot or boot into the Raspberry Pi desktop, so that the PC is a Raspberry Pi desktop, and then I can plug my I can plug the Pi Zeros into the desktop, just a USB right into the computer, and be able to access the pins and things. So I've taken like a $35, $55, or $75 computer, made it a $15 to $20 computer, and I only have the one cable. I don't even need a power cable at that point, because the USB cable would be the power cable.
What's the benefit of the dual boot over the VM, using a VM?
I don't know if the VM will connect to the Zero. I haven't tried it.
Oh, okay, cool.
We can try it. I mean, I think that's on the list of things to try.
Right.
So I think that right. So yeah, and I agree with that. So if you can do a VM, right, and you can still connect, then that's great. But if you can do it, if it doesn't pass through, I don't know if it's going to pass through or not. I think that's going to be my answer until I test it. I don't know. I know for a fact that the dual boot for us works great, right? Because then it's either Windows or it's Raspberry, right? It's one of the two. Yeah, so we can do that. I can test that. We'll see what happens. But that's on my list. I know because from earlier this week, the VM is on the list, and then we're going to see if it'll pass through. It'll pass through. Then at that point, yeah, you can set it up, and I'll send out an email later this summer when we figure that out, unless somebody else figures it out for me. So, does that make sense? So I just want to share that kind of as a thought. Like, I know a lot of you are struggling to try to figure out how to do this in, whichever environment you're in. I am fortunate that I have an environment that's rather flexible, because we've had the conversations with IT and the security officers and the CTO to have them understand what we're trying to do, right? We're not trying to circumvent their security. We're just trying to teach the students. Right? So, and there needs to be some flexibility, for us. I mean, our argument was there needs to be some flexibility there within the realm of that. And, so we've sandboxed off that room, and we have an internet connection to, out, but that's what we've been able to do for us, right? Anyways, okay. So all kinds of good stuff. Like there's, I don't know, we got 20 different websites that we talked about this morning that I shared, and I know kind of rapid succession, and it's, again, overwhelming. My brain hurts as well. But I don't want to get to the end of the week and go, man, I should have shown them this, or I should have shown them that. So with all of that, that's all been shared. I think we'll be in pretty good shape. All right, let me grab out. I'm trying to find my book. Here's my book. And I want to actually, let's take a look at, I want to take a look at this. I didn't get a chance to look through this, but right, so meet the Pico. So I'm wondering how close this is going to be to, oh, this is the other thing. See this piece of right here? What I did today was, I don't have the chat up. So if you guys have been chatting and I have missed something. All right, yeah, okay, good. I'm caught up. So, this graphic here, like I just right mouse clicked and saved the image from this graphic. And then what I did with it is, I'll show you what I did with it, so that when I find a good pinout like this, I try to make sure that my students have access to it. So I have one for the Raspberry Pi, and I've got, I printed off like 4 on a piece of paper and cut them. And I have a stack of those in the classroom, so they have a physical, reference right there next to their Raspberry Pi. My hope is to have, old school laminated, right? Just so they get, they don't get messed up and But this is the same kind of a thing. And I wasn't 100% sure how to do it because I have, I'm an old man and I have my eyes, I've been sitting in front of a computer for 30 years. So this is what I did with it. I took the graphic and I turned it sideways on a Word document and printed it out as a full page, right? And then I just put my Raspberry, my Pico there. So then I can count, right? So it's not, I'm not too difficult to count. But this gives me, what, as we're kind of figuring out how to program it, things like that, I can just do my counting that way. I have a little pointer that I use, right? So it's easy to kind of count through. So just an idea. But I would have these printed out. You could probably do, 2 on a page, if you wanted to have them printable for the students, because most students have significantly better eyes than me. So they can probably pretty easily read it, but this is a really good layout version of this. Okay. So then this thing goes to installing Thani. Pretty cool. There's actually, so I didn't know this, but this is the firmware. So this is where we added that little, we copied it over on the first time we did it, right? But this is actually kind of walking you through how to do the firmware installation. Okay, but I believe when we plugged it into the PC and we copied that little UFG file or whatever it was, UGF file or whatever, that was the firmware. And then using shell. So looks like we can use shell. Oh, this is just shell down below right there, Thani. So you can send commands to Thani. I'm kind of going through this to kind of understand if it's a lot different than what we're talking about. This one right here pretty much is, so this is real similar to what we were doing before. That's a new one, right? Pin and timer. Timer's new as well. So this has some different things. Maybe, I don't know if these are in the book or not, but I'm just curious to see. So this may be another option for kind of going through, right, how to put this together. So this one's using timer to set a frequency, and then you just blink on a frequency. Interesting. And then PWM, right? So we're pulling PWM so we can dim the light or make it brighter. So yeah, this is pretty neat. So it's only going to do LEDs. Looks like LED and an analog input. So this is a potentiometer. So I know that's in the book as well. And then I guess there's some power. Okay, so this one's a real basic introduction, it looks like, right? So we're just gonna blink the LED on board. We're gonna add an LED and a potentiometer. We're gonna do PWM, right? So maybe as a start point, that would be a good lab to do. But I just wanted to kind of go through it real fast and see how it looks. Awesome. Okay, so we're going to start at chapter 4 in this book, right? Chapter 1, kind of get to know the Pico a little bit. It also talks about how to solder on the headers. You guys already know I'm a big fan of pre-soldered headers. We don't teach electronics any longer at CNM, so and access to the equipment is hard for us. I do have the lab. It has one set of soldering equipment, and we have a new extractor coming, so we can actually solder without worrying about setting off alarms. But it's not a classroom kind of thing. So I have them buy the pre-done headers. There's a little bit on how to program with MicroPython. It's an introduction. I think for brand new students, probably have them go ahead and start that. as part of this process. So they have a basic understanding of MicroPython. It's just going to add to whatever else you're teaching them in Python. And then we talk about physical computing, and that's going to be the introduction to, and this is going to be things, all of these are kind of real similar to the Tinker kits, right? So I currently use the Tinker kit. Tinker kit tutorial, right, or activity guide. So this is what I currently use, right, which is a experiment guide, right? And these first 3 chapters or so kind of like the same over here. Like here's the kits and here's some reading that you can do. This one actually, and I actually have my students do some of these readings. I've been working on a little quiz to make sure they've done the reading. So they have a basic understanding of some basic electronics. I'm not trying to get them too far gone into that because we're not really teaching electronics. But like, this is like the whole getting to know the Pico. Here's the red board, right? Here's the IDE, which is, you know, the MicroPython component. You know, if you need some drivers, here's the drivers, but then we get right into the circuits, and the circuits on each of these circuits, every time you start a circuit and you have a new item, right? Like in this case, this is the very first one, light emitting diodes. So go read this article about light emitting diodes. You click on that and you go out, and here's a whole thing on how light emitting diodes work. And then there's actually links out to other web pages. So, right, we kind of integrating, you know, I like them to kind of know what they're doing other than just wiring it up and running it, right? So we're trying to add those in. So with the Tinker kit, I have them, there's certain things that they have to read and cover and answer questions on, and then they do the labs. Over here, these first 3 chapters kind of highlight a lot of that same kind of stuff, right? So just to get a sense of how I'm using, or how I plan to use the book, right? Then we're going to get right into physical computing with the Pico. We need to, because we're going to use Thonny, we need to connect to our machine using VNC. I'm looking for 106. And now this first one, which we did yesterday, but we're going to go ahead and redo again. There's an LED on the board right next to the power, like where you would connect the power. So what you should have at this point, let's do this real fast. So bring this over so everybody can get to this point. You should have a VNC connected to your Raspberry Pi. So here's my Raspberry Pi, or if you're on, right, if you're on your Mac or your PC and you've got Thonny, just make sure it's connected like we did the other day, right? Where you follow the instructions to copy over the firmware, and then once you restart it, you can connect to it on that at the bottom of Thonny. You click on the, like it says Python, whatever version of Python, and you click there and it give you an option to choose the Pico. But I have, this is the Raspberry Pi that I'm connected to here. And I'm using, I didn't plug it in, but I'm using a USB cable plugged into my Raspberry Pi to connect my Pico, right? And I've got my Pico already mounted to a breadboard, right? So just went across the center there so that I have access to a set of pins on either side so that I can then connect any of those pins based on the drawing that I have here in the bottom. Okay, so this is where we want to get. Everybody get to that point. Powered on, connected, Raspberry Pi, VNC, or if you're using your local machine, and then we want to have Thonny up and running. So here's Thonny. Try to make it smaller so we can see it on the screen. You can see right down here, if you click on that, you can see I'm connected to the Pico. Right here. Cool. So what we'll do, I don't know where everybody's at as far as that setup is concerned. What we'll do is I'm gonna pause for say like 5 minutes and everybody get to this point. In the book, we're here, the first physical computing program, hello LED, right? It's gonna be the very first, right? Chapter 4. We wanna be there. We wanna have Thani. We wanna be connected to the MicroPython. So however you're gonna connect, get to that point. And yeah, let's take a 5-minute break. It's been about an hour now. So let's take 5 minutes. Make sure everybody gets here, and then when we get back, we'll just start doing these assignments. All right. I'm muted. I'm glad Zoom is telling me that. Anyways, obviously in the book, they're gonna, the idea of this is to kind of explain what's going on. Oh, cool. All right. I'm looking at the comments in the comment. Anyways, the book explains what's going on and kind of teaching the students about all these things, right? But they're going to typically kind of do what we're going to do today, which is jump down into the code, right, and do the code right away, right? So, however, right, so there's things that they talk about up here, right, there, why we're importing these things, what the libraries mean. The machine library contains all the instructions MicroPython needs to communicate with the Pico, right? So which every time we're going to run one, we're going to run import machine. Okay. And other MicroPython compatible devices. So extends the language for physical computing. Okay. Allows us to control the pins, that kind of thing. And then here we're just doing this is, this piece of code, which is we did this code yesterday, but the idea of this code I keep watching the comments. I should just block those out. So, this one here, we're making we're making a variable called LED onboard. Yesterday, I shortened that to LED equals to machine and pin, right? Because up here we import machines, so we're importing everything, and you'll see like the examples, that example from the tutorial that we just did. They from machine imported pin, right? So then you don't have to have machine.pin here to do that. So there's a lot of times I'm looking at this going like we're making this a lot longer than it really needs to be, in the way we're doing things. So, and they kind of talk about you can make this whatever you want it to be. And then the value of 1, that's an on, right? Value of 0 is an off. Type of deal, and then U time. So they're going to explain U time, right? So import time, import U time. So U time is going to be, and we did that to import from U time import sleep to get rid of the fact that we had to do this little deal as well, right? So the point I'm trying to make here is like, I think I'm maybe preaching to the choir, but the idea is like you want the students to kind of go through this material. And instead of just going right to this, right, so that they learn it. Or what we probably should do, and this is probably the easiest thing that I like to do, is when we type these in, I just verbally explain what they do and what's going on there. So now I'm interested because the U time versus time, right? So you program Python, you probably use the time library. The U time library is a version designed for microcontrollers. Okay, so that's what's going on. So the U stands for, right, does anybody know what that's called? It's a Greek letter. I don't know how to pronounce that letter. Mu, right? So, so shorthand for micro. If you forget to use import time, don't worry. MicroPython will automatically use the UTime library instead.
So
Right.
I like to have my students comment when I go through and do these things.
Okay.
What's the comments? Can you do comment symbols in MicroPython? The hashtag?
I'm gonna assume we're gonna try it. I would assume hashtag is gonna be the, yeah, looks like it is.
Okay, thanks. So,
Comments here.
I just didn't see it in the book. Thanks.
No worries. Yeah. Yeah. No, that makes sense. So what I'm liking already is that, and I think we talked about this yesterday, like a lot of these things are the same kind of way you would do it on, it's just using different libraries. Like that's all we're really doing. So, right. So in this case, right, import.
I'm
Yes.
sorry. I'm sorry, Fred. Can you go back to the connection just to make sure that I have it connected, right? The picture that you have in there.
That guy?
Yeah. So does the pins have to be like all the way down, or they're just touching the?
They need to be pushed into the board.
Oh, okay.
Because if they're not pushed into the board, actually, I have a. Let me show you. Hold on.
And it doesn't matter where that connected to the breadboard, right?
No, it could be anywhere, you know, this way, right? You do want to bridge, the gap there, right?
Right.
So we want to have this set of pins on one side of this gap and this set of pins on the other side. Because if they're on the
Okay.
same side, which you shouldn't be able to plug them in on the same side because they're wide enough.
Right.
So they create a different circuit. But what's going on here, and this is if you've never seen the inside of a breadboard, right? So this is what's going on inside of this breadboard. There's actually these little metal plates. So if you don't push your pins all the way down, it doesn't make contact. And if it doesn't make contact, we don't create a circuit. Okay. And then for each row, each of these rows here, there is a separate pin, a separate set of pins, right? So this row is not connected to this row. And because there's a gap here, this first row is not connected to this side. So just, you know, for students to see, I really like this to kind of show them how what's going on the inside of the board, because this kind of hides it. So if it's not pushed all the way down, you're not going to make contact. And a lot of students, especially with buttons, they get real timid about being aggressively pushing the buttons down, and they may bend a pin, right? Very rarely do they ever break a pin, but they may bend a pin, and then you just pull it back out, straighten the pin out, and make sure it's lined up a little bit better. But this one went in fairly easy for me, and I did it when it was unplugged. I don't like to mess with it. You know, I wouldn't want to push down on it with my fingers while it's plugged in. But it's seated all
Right.
the way.
So it goes all the way down, right? Like
Yes, sir.
all the way touch the
The
thing.
black right there is touching the top of the, and it's just basically to just kind of take it and push down as evenly as possible, right? Because if you could bend pins if you kind of have it, if you have it wonky.
Okay, let's try that.
Awesome.
Yeah, very good. Thank you.
All right, so the very first line here, import machine, like we looked up above, right? As we were reading, machine allows us to communicate with the Pico. Okay. Now, if I look at the rest of the program from the machine, right here, machine pin, we're going to use only pin. Right. So this is where. Back arrow. I just did some crazy stuff on my. I got to keep switching back and forth. My bad. Let me go back. Here. Okay, here we are. So over here, what I would recommend, right? Let's just get just the parts we need, right? So we can do from machine import pin. Right. So I'm gonna already kind of take off track, right? So we only need pin from machine. And instead of me having to type machine every time I want to access, I want to bring up pin, I can just type in pin because I'm importing pin. Okay. So then we're going to enter I got to be over here to enter, right? And then from UTime, and then we're going to import UTime. So they want to import the whole module. Again, all we need is sleep, right? All we're using is sleep. So I would say from UTime, import sleep. Okay, so these are the libraries that we're pulling from, and these are the classes that we pull. And then here, this third line, we are assigning a variable, right? And we're connecting that, basically creating a variable and connecting it to pin 25 on the device, on the Pico, and we're assigning it as an output device, right? That's what this whole line is doing. So a couple things going on, like that's a really long, for me, that's a really long variable name, right? Because you have to type it every time you want to address it. So for this particular assignment, I'm just going to call it LED, right? So we're going to call LED. And space equals, right? So we're creating the variable LED instead of LED on board, and we're going to equal it to this, right? Now, because I made this change from machine import pin, I don't need to address pin with machine.pin. I can just address it as pin because I've imported it as pin. Okay, so then it's pin, open parenthesis, we're going to assign pin 25, right? And then we are also going to then make it a pin.out, OUT capitals, right? And then capital P for pin. So that shortens up this entire line, right? By doing the import this way and only bringing in the one item that I need to use on this particular program. All right. And then the while true loop, right? So then now that we've imported the libraries, and in fact, we imported just the classes that we need for this program to run, we've set the variable to connect it to pin 25. If I scroll up, they explain here, right? There's an LED on board and it is connected to pin 25, okay? So general purpose pin 25. All right, and then while true. So while true, colon. And then right here it says LED onboard dot value 1. So I changed it to LED. So it's going to be LED dot value. So we're setting the value of this variable, right? This variable here, which is pin 25 and output, we're setting that to 1, which in, you know, Arduino land, microcontroller land, 1 is on. And then utime.sleep 5, right? So we don't have to use the utime because I imported sleep individually. So I can just go sleep. And 5 is way too long. We've already had this discussion. I'm going to go with 1. So, and then, right, so then in the while true loop, I'm going to turn it on and I'm going to wait, right? Sleep doesn't turn everything off. All it does is pause. With whatever the last thing you were doing, it just keeps that going for however long, right? So in this case, 1 second. Then I want to do LED.value 0. That's going to turn off the LED. And then we want to sleep for 1 second as well. All right. So that would be the program. So this is the modified version of this. This should do exactly the same thing that this did. If I bring over, right, here's my Pico. Okay, I'm going to click run, and I'm going to save it. I'm going to save this program to the Pico, right? I want this program to go from here to here so that it runs. Okay, so this is, if you've done anything on Arduino, when you do the whole upload, right? That's exactly what we're doing. We're sending this code to this device so this device can run this code. So we're going to click on the Raspberry Pi. I'm going to call it, I'm just going to replace the one I had yesterday, LED blink. And yes, I'm going to override it. And you can see now that I've got a flashing LED light. So the other thing now that I'm curious about this now is that there's a pin 25 doesn't exist. So, okay, so pin 25 is only this, right? It's not, as I look through this little list of things, I got 28, 27, 26, 22, 21, 20. There's not a pin 25, right? So on the Arduino, this is pin 13, and pin 13 also exists as a pin that I can plug into, right? So 1, 2, 3, 4. So it'd be 1, 2, 3, 4. So it'd be right here, right? If this was an Arduino, this is not an Arduino, right? So they didn't double wire that, right? It's not wired to another pin. It's only wired to the onboard LED GP 25, pin 25. Yes, no, maybe so, kind of, sort of, makes sense. Awesome. So that was we did that one yesterday, but I think a lot of times when we're doing these, especially when we do these in class, as I type out the lines, I try to explain exactly what's going on, and we do it over and over and over again so that we make sure that they understand, what's going on. Okay, now there's another way to do this, right? So remember the lines outside the loop are indented by 4 spaces. So when I entered it, it was automatic, right? What do we have doing here? So there's another way to handle the same job. You can use toggle rather than setting the LED output 0 and 1 explicitly, right? So instead of all of this mess here, right? LED value on, sleep for a second, LED value off, sleep for a second. We can do LED toggle. So I can change my code right here to toggle. We don't need to hand over any timing mechanism. And then I can get rid of these 2 lines, right? So I can eliminate 2 lines of the code. So my code's a lot smaller now. And what I'm gonna do this time though is I'm gonna change the sleep to 2 seconds so we can see the distinct difference between the flashing, right? So if I click, let's do save on this one. Oh, device busy, can't. So I guess I need to, where's my stop? I think there's my stop. So I'm gonna hit stop so that we're not sending so you can see my program stopped over here. Okay, I'm gonna save this. I didn't want to save it that way. I wanted to save as, but we're gonna run it anyways, right? So we still have LED blink, but now we're toggling. But I'm doing a 2-second toggle now. So this should change to 2 seconds. So if I click run, you see my flashing turned back on and my timing now is at 2 seconds, okay? So I saved 2 lines of code. I saved, there's 2 lines of code that I don't need to have there, right? By using the toggle line versus the value 0 and 1. And you can see it happening here. Very cool. All right. Dun, 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 dun. That's it. So run the program again. You'll see the same activities before. Onboard LED will light up for 5 seconds, go off for 5 seconds, light up. So we're doing 2 lines shorter. You've optimized it, right? So that's we've optimized it. We've made it. I mean, I tried to make it as small as possible. I've already kind of like, how can I get my variables down to smaller as possible? That kind of thing. So what do they want us to do, right? So available on all digital output pins, toggle switch simply switches on and off. If the pin is currently on, toggle switches it off. Toggle, if it's off, it switches it off. So then they do get into how to use a breadboard, right? So, and we've kind of shown you that like each of these rows on each side of the break in the middle, like this is a circuit, this is a circuit. And then on the verticals, right? And what I mean by verticals is where the red line is and where the blue line is. These are all actually wired together. So everything on the red side is all connected together and everything on the blue side is connected together. And they kind of show you that in this diagram here, down the side of the boards, right? So if I plug in something here in this first blue one, and I plug in something over here in this blue one, they will be in the same circuit. They're part of the same wire at that point in time, right? So they go through and explain it, and then this is how we want right? This is how the board goes in. It's designed to sit securely in your solderless board, okay? Now we're going to do an external LED, right? So we've done the internal LED where you still have that program is still running right here in the background. And now we're going to do an external LED. And we need to, in order to do external LED, we're going to need, what do we need? Does it tell us, right? It doesn't tell us. We just got to figure it out, right? So 330 ohm resistor, I'm sure it does. We need two wire. We can do this 2 ways, right? This looks like, right? I could wire from here to the outside board and then wire from the outside board to the inside board. That takes 2 wires, or I can wire from here to here directly and skip that. And then they're doing a resistor from here to here, right? And then I would assume this is probably a ground pin. Is that a ground pin? No, it's not. This other one over here is a ground pin. The third one?
Yep, yeah. The 38.
So this one's the ground. This one is pin, what pin is that? 15, right? So pin 15 is this one right here. Right, so we're using the resistor to do the connection here, and then through the LED, right? And then from here to ground. Okay, so I'm going to use, instead of using 2 wires, I'm going to use a single wire from here to here. And then I'll use this resistor from here to here in the LED. Okay, so I need to grab those out. My kits here. To find them. I see an LED there. Jumper wires here. And those, for those that have never done physical computing wiring, the colors of the wires don't matter. There's 3 types of jumper wires that we use. I think with this particular case, the way we've got the breadboard set up, we're going to use male-to-male wires, which are both ends are pokey, right? Both ends have a pin on them. There are female-to-female wiring, which we don't use a whole lot. Those both ends do not have the pins on them. And then there's male-to-female, which with the Raspberry Pi, we use a lot of male-to-female wiring. And those have 1 pokey side and 1 not pokey side. So I need, I got 2 wires. I'm gonna, yeah, I grabbed out 2. I'm only gonna use 1. So I've got, right, I got my 2 jumper wires. I've pulled out a 330 ohm resistor, and I've pulled out an LED. Okay. On the diagrams, anytime you see an LED with bent leg, right? If you look at your LED, you look at the LED up close, there's a long wire and a short wire, right? So the long wire, I'm touching the long wire. It's hard to see that from that picture right there. See, there's the longer wire, right? That longer wire is the bent wire in the diagram, okay? And then the short wire is usually straight in the diagram. To put these this light in, it can go anywhere, right? On here, we're going to go relatively close to this because we're going to bridge that resistor. I'm going to kind of start to insert 1 wire, and then line up the other wire, and then I just puts the LED down into the. You can bend it so you can kind of see, right? So these are seated, right, into these ports on the breadboard, and I've pushed all the way down so that it's solid on the bottom. Okay. Now, according to the diagram, right over here on the long leg side, I'm going to insert a resistor. So I've got my resistor here. I take my resistor and I'm going to bend the wires so that I have the U shape there. And then I need to go from, I need to be on the same row as the long leg, and I need to be on the same row as this last pin here. And so there and there. So I'm on the same row. I use the plastic side of this so I don't make any cross connects I don't want to make. There's the pin is in the board. This leg here is in the same row as that pin. This leg here is in the same row as this pin. All right. And then, like I said, we could jump her over to this wire, and then we could jump her over here, right? Or we could simply, I'm on the same row there, and then I need to be on number 4, I believe, right? No, number 3. 1, 2, 3. So I go right there. Okay. So up here, this wire here is matching to the 3rd pin, the 3rd little knob there, the 3rd row. And then over here, I'm on the same row as this leg is. Okay. Awesome. So that's the wiring that we're going to do here, the finished circuit. Okay. Now the program. Okay. So the only difference between what we're doing with when we had this little pin 25 going on is now we're connected to pin 15, right? Now we want to push power through this pin to this LED. We don't need this pin, the 25 pin, running any longer. You can leave it if you want, right? You can just add an extra line. But for now, we're going to make one change to the current program. and get this LED light to turn on. And that change is going to be right here where we assign the pin. Okay. So I'm going to bring this down over here so we can see this. Scroll this a little so we can see the code. I'm going to go back to my code over here, and I'm going to change pin 25 to pin 15. Okay. The other thing I'm going to do with this is I'm going to hit stop, right? So that I'm not running any program on the Pico. And then I'm going to hit run again, because now that I've changed it to pin 15, and what we should see if I've done this right, is this light should turn on for 2 seconds and then turn off for 2 seconds. And it does. Sweet. All right. So if you've done that, you've got your first, if you've never done this before, you've made your first electronic circuit. And most of my students, this is their first time ever making an electronic circuit. And I think you'll find that true in most cases. There's something really satisfying about getting an LED light. So celebrate with them when they like, hey, it works kind of a thing. So it's a pretty big deal. This early stage, that's a big deal. Okay. Now, I mentioned, right, I could keep this other light running, right, as well. Okay. And so what I could do is I could have put in here LED. Let's do onboard OB, right? Let's do an underscore OB for onboard. And we're going to make that equal to pin, right, 25. And we're going to set that as a pin dot out, right? And then down here, we're toggling the LED every time we run this code. So we could probably do the same. What I actually want to do is before I get to the while true loop, I want to turn on, I'm going to turn on the onboard. Okay. So that would be then equal to LED dot value. And I'm going to hand it a 1. Okay. Because then what I want to do here is I want to LED underscore onboard dot toggle. So what I'm hoping to create here is I'm hoping that this light, right? I'm hoping that the red light turns off when I stop the program, right? So let's see if that's true. So it does. And then what I'm hoping to do here with this setup is the light's going to turn on and then immediately turn off, and this is going to turn on and that's going to be off, and then that's going to turn on and this is going to be off. Like I'm trying to get them to flip back and forth. That's kind of what I'm trying to do here to see if that works. But just to kind of show you that we can then modify that and add this extra piece into this puzzle. I'm setting the pins, right? I'm setting 2 different pins to 2 different variables. With this variable, I'm telling it, turn it on. We could turn it on and we can also at that point sleep for, say, let's sleep for 2 seconds so that it looks like it's part of this whole process. And then it should toggle off and the LED should toggle on, right? It should work. We'll see how it works. We'll see what happens. I have no idea. I'm thinking it, well, I do. I think it's going to work. Oh, it's not working. It doesn't like something. What did I do? Oh, okay. Oh, wait. Did I type it in wrong? I did. No, I didn't. What did I do wrong? So it doesn't like, object has no attribute toggle, but it's a pin object. Pin
I'm sorry,
out.
why is there a pin out? Why is the pin 15?
Pin 15 is this LED, right? This LED here.
Then why is the other one pin 25?
Pin 25 is this one. Pin 25 is the onboard.
Oh, got it. Okay, yes.
So I was just I'm trying to get those 2 to go back and forth, but
Okay.
oh, I want,
Yeah.
yeah, I don't, So this, did I type, it seems like I typed something wrong, but I don't think I did. Because the toggle worked perfectly fine before, right? So if I do, which line did it not like? 13. Doesn't like the onboard toggle. I don't see where I messed that up. Unless maybe because I said, well, no, you should be able to turn it on. And the other thing I noticed, it didn't when I sent it. Awesome. This is this is what happens when you go and play, right?
You need to have a sleep after each toggle.
After each toggle you do?
It's a question.
Oh, it's a question. I don't, maybe, right? But this one is saying it doesn't have an attribute called toggle, which is weird because, right? There's nothing different here. And pin 15 works. The one thing I did notice is like this didn't actually turn on. Oh. No, that should have worked. LED. Oh, what am I doing? That's silly. I did this wrong. LED. I just need to do that here to turn it on. What I want to see is I want to see that turn on for 2 seconds, right? And then that's toggled. Okay, it's working. I think it's because I screwed up here. So this is what I was trying to get to, right? 2 seconds on, and then they flip back and forth, right? So that was the whole point of this, just to kind of get those to interact and show students how they could play around with things. And then obviously, you know, we got a troubleshooting thing. I did LED equal to, so it does make sense that why there was no toggle, right? What I did is I said LED equals pin, and I set it as a pin, and then I said LED equals LED dot value 1, which it doesn't, that's not what I was trying to do. Like I was trying to set the variable a second time. I just wanted to run value turn up 1 to turn it on, right? So so that's what we did. So this program is what we've done so far with this program. We've got, you know, we've imported pin, we've imported sleep, and this is different than what the instructions say because, right, I just want to bring in only the things I need, right? As long as it doesn't get out of hand. And then what that allows me to do is later on is I don't have to have machine.pin, 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 machine.pin. Right? So lots of typing that I can avoid. But I basically assign 2 variables, LED equal to pin 15, which is this red LED down here. And then LED OB for onboard, right? Pin 25, which is this LED up here. I set those both, I set the pins and I set them both as outputs. And then I turned on, to begin the program, I turn on the onboard for 2 seconds, right? So the onboard comes on for 2 seconds, and then we drop into the true loop, right? And then the true loop toggles, turns on this one, turns off this one, waits for 2 seconds, turns this, you know, and then toggles back and forth, right? So that's what we got to with this one. Okay, again, just more playing around, more adding additional things so the students can see that, hey, you can modify all this stuff. You don't have to, it's not stuck in stone, right? All these things are not stuck in stone. So the next one, we're going to, are we good with that? We're good with LEDs? We did the basic LED? Question.
What reasons would the red light not come on? Because I've got it in the right lane. I've got it in 25. I've got the 3rd pin at the top for my wire.
You have it on, so you just said you have it on pin 25. It's pin 15, you mean?
No,
This is pin 15. Right? This will.
Hold on.
Oh, my bad. Hold on. Where'd it go? Right here. Right? So this is the LED, and the LED is connected to pin 15, which is this very first pin on the bottom down here.
And how do you know it's connected to 15?
Because my little chart right here tells me this is pin 15, and this leg of this circuit is connected to this pin.
Oh, so I'm missing something. I can't see what you have there. Is that an ohm resistor?
This is a resistor.
Oh, okay, that's what I'm missing. I couldn't see it in the picture.
So
It's
right here.
Thank
So the resistor goes to 15
Yeah,
onto
that's
the
what I was
long leg,
thinking.
and then the short leg goes to ground, which is the third pin way over here.
Thanks.
The other thing to be aware of, right? So the way the graphic is drawn, it has me coming all the way up here to pin 30, whatever this pin is, this third pin up here, the ground pin. There's also a ground pin down here, right? The third pin down here. So if I actually move this down to 1, 2, 3, I should get the same exact thing, right? So as long as I'm connected to any of the grounds, right? For those of that are new to electronics, as long as my circuit is connected to any ground, I'm good to go, okay? All right, now, we good with that one? Any other questions on the LEDs? Again, we added a little bit of stuff here. I mean, you don't have
I'm just
to.
trying to get the first one to work, which is
Okay.
basically the one on board, right? The light on board, right? That's
The onboard, right.
it's supposed to work if I just,
This is the onboard.
okay.
So on your Thani, you have it connected down here to the Raspberry Pi Pico.
Right.
So to get the onboard to work, we can change the code here.
This pin 25 has any significance, or it can be,
Pin 25 is this light. This light, that onboard light is connected to pin 25. It's the only thing connected to pin 25 is that LED on board right there.
okay.
So are you following what I'm typing, or did you follow this piece right here?
No, I follow what you typed.
Okay, so then make sure we get it. So we don't need the comment here. We were just checking to see if comments worked. Right, so from machine, import pin. From U time, import sleep. No problem, Lily, have fun. And then this first one here, we don't need this one. This is the LED, right? And right, I had done something like this, right? So LED equals pin, capital P, right? Make sure that's capital, make sure that's capital.
Right.
Parentheses 25, comma, pin, capital P, dot OUT, capital, all capitals. Not worried about this one either. Not worried about this line either. And not worried about this line either. So this right there, right? If you do that, then that pin should light up.
Okay.
And the first time you run it, it should have asked you just, do you want to do this local or do you want to send it to the Pico? Definitely send it to the Pico.
Yeah, let me troubleshoot that a little bit there.
Okay. All right.
Thank you.
No worries. No problem, Rick. See you a little bit later. Looking at the comments. All right, so external LED, we've done the external LED. I'm scrolling down. We're gonna get down to you can modify the program to light up onboard. So I did this challenge without reading this, right? So this is the kind of things that I would want my students to kind of start playing with. And maybe what I've found is lately is not like in the Tinker Kit programs right now, is I'm not worried about them being able to follow the instructions and get it working. I mean, obviously every once in a while you'll run into struggles and it's being weird. But like, I really want them to be able to do the challenge, right? So the challenge there was to add those extra pieces, and that way then I know that they're starting to understand, right? Or it forces them to understand. So usually my assignments are, the end result is complete this challenge. After doing the assignment, complete this challenge. And then that's what I want to see as the end result, is this challenge, right? I want to see that toggle back and forth kind of a thing. All right. So we're moving on to import reading a button. Okay. So then I really like how they do these things where they add these, like, you know, the resistance is hidden, right? So that we don't need a resistor for the thing because it's built into the button. Right? So you can see that we took the resistor off of this little corner here. This is interesting too, that this button, you know, normally when we wire a button, we wire the same side, right? This one having us wire one pin on one side and one pin on the other. So I've never seen that work, so we'll see how it goes. So we'll see how it goes and see what happens. So the first thing we need to do is wire that up. So what I'm going to do to begin with is I'm going to hit stop on the program so that the program, you know, stops where it was at. And then I'm going to leave the LED in place, right? And we need to grab a button. We don't need any resistors, but we also, for this project, it wants us to have two wires. So button and two wires. So got these really fun, fancy buttons. So nice and big. I have another pile of them, but I ended up going to I went to a Micro Center, and in there, or was it may have been a Fry's before Fry's closed, but in there, they had these big bags of buttons. Like I bought like 100 of these things because I just like these better than the little chintzy ones that come in the kits. I need two more wires. So the other thing, I don't know if I can show you this or not. So I'm using these little hyper tough boxes. I have a big Arduino kit, right? So I got all, you know, and I've got actually two of them. Like they connect together. So you'll find like some kind of organizational tool like this allows you to kind of have all your little parts and pieces. Like all my little extra red boards here, the maker boards, and all the little parts and pieces. Here's potentiometers for later on, right? But I've kind of collected up all of the Arduino specific physical computing things, and I've stored them here in a container so that I can get access to them anytime I need to. But yeah, so that, you know, instead of like this leaving in a box or whatever, it's a little bit better organized this way, a little bit more control of what's going on. So I need two wires. I got some pretty long ones this time. See if I can find a shorter one. This one's ridiculous. That's really tiny. These wires come in all kinds of flavors. There we go. Right, so something like that. I got plenty of wires to do this with. Okay, so let's take a look at the wiring here. And I want to put this wiring here so we can see what's going on. And what we want to do is they have us connected to a different ground this time, it looks like. Actually, what's going on here? They have us connected to the second, so 14. Right, so you can see I'm connected down here to 14. And then over here, I'm connected to 1, 2, 3, 4, 5. The fifth one down, which is 3 volt power. So we don't have a ground on this one because we're just running power through it. Okay, we'll see how that works. I'm going to go ahead and just plug it into the board. And to plug this into the board, right, you can see I've got it lined up. And then literally I'm going to press it down where it clicks into place. And students are always afraid to do that. Like you see, it's solidly set down there. Right? These nicer buttons line up really well. If you get the little cheesy buttons, the really tiny ones, right? They're not so kind, but they still work, and you still need to be aggressive to put them into the board. So don't be afraid to push them into the board. Now, to wire this up, the blue wire here, the blue wire is going from
14. So I'm going to leave the LED in place. And it's going to the first, looks like the first pin here. So what I'm going to show you, hopefully you can see that. Right there, yeah, you can see it. There's my little poker. There it is. Right down here, I can see that my little metal, right, it's kind of right at the tip there. There's a little my metal pin is in this row, and I've actually connected this wire to the same row. So now that pin and this wire are the same thing, okay? The other side of this needs to be to power, right? So to power, which is, and I'm going to connect to the other side. I'm going to connect to this pin way over here on this side. And then I'm going to connect it to, I think, the fifth one up here, which is 1, 2, 3, 4, 5, which is the 3v3 out. Okay. So the go ahead and connect here. So that's on the same, connected to the same line as that, and then I'm gonna go 1, 2, 3, 4, 5. 5. 1, 2, 3, 4, 5. So this is 3v3 power through the button, and then coming out the other side to pin 14. So that's the wiring, and you can see I just left this other one in place. So unlike the button, the push button doesn't need a current limiting resistor. It does still need a resistor though. It's known as a pull up or pull down resistor, depending on the circuit works. Pull up or pull down resistor, then put known as floating, which means it's a noisy signal, right? So it's nice to explain how these things work, right? So yeah, I love those kind of things for the students to know. So then the program, let's take a look at the program, right? So wiring is there. The wiring, you see the example over here. I'm going to move that off briefly. And we're going to take a look at the programming. Right, so we're going to do the import machine again, and then this time we're using pin, right? And we're making it an in and a pull down. So we're telling it what this circuit is like, and that's explained up here. Right? Pull down resistor connects pins to ground, meaning that when the push button isn't pressed, the input will be 0, and when it's pressed, it'll be 1. Okay, so that's what's going on with a pull down. Okay, so we import machine, right? And then we're going to assign a variable called button to machine pin. We don't have to do this. We're still using pin, and then we're going to print button value. Is that all we're doing? Print button value. And then if you press the button, it'll say you press the button. Okay, let's take a look at that real quick, right? So we don't need, looks like we need machine. Do they leave sleep in? Yeah, so they leave sleep in. They don't tell you about sleep up here, but we need sleep, right? Because it's in the code. So import machine, import pin. So pin is what we're going to use. So you can see it right there. UTime import sleep. We need sleep. And then instead of using the LED, we can leave the LED. No, we don't want it. It doesn't matter. We can leave it assigned. We're just not going to use it. Okay. Button equals pin, right? Because we imported pin. We don't need to do the machine component. We're going to be on pin 14, and we are making this pin an in pin, so it's looking for an input, and we're also making sure that this pin is set up as a pull down, right? So meaning if I press the button, right, the value is 1, and if I don't press the button, the value is 0. Right, so button equals pin 14, comma, space pin dot in, space pin dot pull down. So then while true,
we're gonna comment out the LED there.
Oh,
I'm gonna leave them there, but I'm gonna just comment them out because we're not gonna use them in this particular deal. Okay, so while true, if the button value, so we're asking the question if the button value is equal to 1, which is on. So if the button is on, if I'm pressing the button, then I want you to print, and this is going to print on the screen down here in the shell. You press the button. All right. And then we're going to use sleep and sleep for 2 seconds. So in between, right, so if the value is 1, it's going to print this. It'll put it on the screen for 2 seconds, and then it'll look to see if the button's still pressed. Okay, does that make sense? So click the run button again. This time nothing happens until you press the button. So we're hoping, right, that if I'm gonna hit stop, so whatever's going is not running. So the program is my program looks a little different, but I've kind of explained how we got there. We're importing pin instead of all of machine. We're importing sleep instead of all of U time. We're setting the button equal to pin 14, which is on our wiring here, right? So this pin right there is 14. And we're making it an input. So the machine is looking for a value to come from there, not to be sent to there. It's a pull down, meaning if it's closed, then it's a 1, and if it's open, it's a 0. And then we ask the question, if the value is equal to 1, if you've pressed the button, I want you to print, you press the button. And then I'll wait for 2 seconds, and then I'll go back up and check to see if the button is still pressed. Okay, fair enough? Let's see what happens. So I'm gonna bring this over. We're gonna hit run. Right? And what I should see is on the screen, I press the button, right? So I'll press it again. If I press and hold it, it's gonna continue because every time it's checking, every 2 seconds when it checks, I still have it pressed, okay? But if I let go of it, right, it's gonna stop, right? So we can see there's 1, 2, 3, 4, 5, 6, 7, right? If I press it again, right, you can see my cursor went up 1, right? So I press it again, the cursor goes up another 1. Okay, so we know that we're registering the button press through the circuit, and we're able to to show on the screen here that we press the button. Right, so now we have an input, we've done an output, right? And we've done an input. My thinking now is, how do we combine the two? Can I trigger the output with an input, right? And I think we can, right? So the inputs and outputs, putting it together. Okay, so that's interesting. That's exactly how my board looks, right? So good. So because I left this together, so we're all in good shape there. So what we want to do then is we want to use the button to control the LED, right? So we're going to create a circuit that allows me to control the LED.
this close to. Can you show us your board again?
Yeah.
It just helps.
So I left the wiring for the LED in place, right? So the wiring through the resistor is connected to pin 15, that very first pin there. And then this wire, this red wire here, I moved it to a ground just to show that I put it on this ground down here. You can leave it on this ground up here if you want. You could put it here, you could put it there. Looks like there's 1, 2, 3, 4,
5, 6, 7, 8. There's 8 places where you could plug in the ground wire. That's this wire here. Okay. For the button, right, on this side, I've got this first pin, that first pin there, connected to pin 14, which is the second pin on the Pico here. And then on this side, I've got the opposite pin, the pin like diagonal across the button there. I've got that pin connected to my 3v3 power, which is number 5, I believe, up here, the 5th spot. 1, 2, 3, 4, 5. Okay. So that's how I've got it wired currently. This light is still on because we paused that, or we stopped that previous program and it was in that state. So it's still in an on state. So pin 15, this pin here is still in an on state.
Okay, so I have that one. The one that the red one that's connected is supposed to be 14. It's hard. It doesn't look like 14 here. It looks like 13. The red on the right, the red wire right there.
This wire?
No, the other side, the red wire on the right-hand side. Keep going right. Yeah, right there.
This one?
So that's on 13?
This pin here is plugged into that. This. Are you looking at the lines
The one
here or
right
up
next
here?
to the Pico. Next to the Pico. Go up right there. That one, that wire right there that you're touching. What
This
pin
one,
is that on?
this wire here.
Yeah. What's
I
the one
have
next
it
to the
right here. It's on the LED, and right here I have it on the ground wire, which is this one right here.
Okay.
23.
Thanks.
The instructions have you put it on 38. And I moved it down here just to show that you can be on any of the grounds. Right? So as long as you're on any of those grounds, right? 18. You could put it on, this right here if you wanted to.
Oh.
And when I say pin 14, like see right here, GP 14, that's what I'm talking about. I'm not talking about these internal numbers here. These internal numbers are the physical 1 through 20, right? And 21 through 40, right? Because there's 40 pins on this thing. But what we're going to address are the green, right? Unless we're doing like I2C or SPI, right? So on here, when we're addressing it programming wise, we're doing it via the green ones. So 15 is actually pin 20, right? On the Pico, and 14 is actually pin 19. But for the ground wire, which is this wire here, as long as this end that's down here by the Pico, as long as it's plugged into any of these black grounds, it's going to function the way we want it to function. Does that help?
Yeah. Can I see the code again? Because I get the button to work.
Okay.
I get the press the button,
Awesome.
but I need to check the light. So
All right. So we haven't done the light yet. So we're doing the light now.
Okay.
So we're down. Yeah. So that's the section we're talking about right here. We just got this. So this is wired. This is what we just walked through. This is how we got it wired. And the code, right? So what they'll do, they got import machine and U time. We're good. I've already, like they have, LED external. So we're just going to bring back our LED and we're going to bring back pin 15, right? So that's where this pin is already connected on our board. Okay. So LED is on pin 15, pin out, right? Which is essentially what this line is doing right there. And then we still have the if, right? To create the loop, reads the value 1. And then if you press it, right, we're going to turn on the light and we're going to sleep for 2 seconds, right? So then all we really have done now, instead of toggling, which we could toggle, right? So the way the code is written, let's get rid of this. So the way the code is written is if I press the button, right?
it doesn't have to tell me I pressed the button. I'm gonna leave that in there just because. And then what we're gonna do though, whoops, I wanna go down here. I wanna do LED, right? Dot value of 1, okay? And then I need to sleep, not leap, sleep. So if I press the button, if the value is 1, print, you press the button, and then at the, essentially these happen at the same time, turn the light on, and then sleep for 2 seconds, okay? The issue then is I need to then turn off the light, right? Which is not gonna be inside of the if loop there, it's gonna be, right? That's the line up here, right? So if it's 1, then we're gonna do this. If it's not 1, then this is what happens. So it means turn off the LED, right? So if I'm not pressing the button, then we'll turn off the light, right? Which is a LED value 0, right? So LED is our variable. On the example, I could, LED underscore external, right? So I just get rid of the extra writing. LED is if in the loop, if I press the button, it's going to print, you press the button, it's going to turn on the light, it's going to go for 2 seconds. And then it's going to come back to the top of the true loop. And if I'm not pressing the button, it will turn off the light. Okay, so that's the code provided. So I'm going to hit stop and I'm going to hit run. And you saw, oh, you didn't see it. The light turned off, right? The light turned off, and the light turned off because I'm not pressing the button. And it hit, right? It asked the question, is it on? And it wasn't. And it said, okay, turn it off, right? So now if I hit the button, the light should come on 2 seconds, and then it should go back off. And I hit the button, it comes on for 2 seconds, and it goes back off. So hit the button, and then it's also saying down here, you press the button, right? So when the program runs, it imports pin, imports sleep, it assigns the LED to pin 15 as an output. It assigns the variable button to pin 14 as an input with a pull down, right? And then it goes into this loop and it asks the question, is the button pressed? That's what this question asks. Right? And if it is, it says you press the button, turns on the light, waits for 2 seconds, and then it starts the loop over, right? Back up to the top of the loop. It asks the question, if you're not pressing the button, then it drops down and turns off the light, okay? So that's what this is going on. So the camera that I'm using right here is a Ladybug from Lumens. I think it's a DC 193. Something like that. Yeah, this is what I got. So we got this camera. I don't know how much they cost school. I got it from school. So, and I love them. They're awesome. And I had to fight them to put, I have one in my classroom too, so I can display the Raspberry up on the big screen. But this is a really great camera. I can zoom in, I can move things around. But it allows me, like you say, like, it's hard to teach this stuff online unless people can see what's going on. I can just bring that up and you can see. And then if I make it really big, I mean, right, that's give me a lot of good detail there. Yeah, so that's what I'm using. All right. So yeah, so this program functions, right? And this is also too, because I can show you what it's supposed to look like, right? So that's awesome there. Now I saw a challenge. So can you modify the program so both lights, the LED and the print status message to the shell? Oh, I just left it that way. So, oh, I think their one here, they get rid of that message. I left the message in. So that we cheated. Now, my challenge, I'm thinking, so the challenge that I have here is, can
if the button is pressed, I want the red LED to turn on, right? So if the button is pressed, so here's the challenge that I just created for myself, right? If the button's pressed, I want this light to go on for 2 seconds, right? So I'm fine with the code for that. But what I want to is if this button is not pressed, right? Then I want that button to be on. I want this light over here to be on instead of this light, right? So this would be like a green indicator light, right? And I want to be able to press the button and turn this light off and turn this light on for 2 seconds, and then go back to a green light, right? So that's going to be the challenge that I want to try to solve here. I just freaked out because oh man, we ran out of time. We have another 40 minutes before lunch. Good. Okay. So that's going to be the challenge. So the challenge then is let's use LED underscore onboard again, and we're going to set that to pin 25, right? So that's the onboard pin, and we're going to set that as a pin dot out, OUT. Okay, so we've set that variable, and then before we start the loop, we want LED underscore OB to be on. All right, so that should do that. I don't know about you, but I really like the fact that we're doing all this in Python. Anyways, okay, so and then while true, if the button is on, then I want you to press the button, turn this one on, and I want you to turn LED underscore OB dot value to off. Okay, and then if it's not 1, then LED value 0, and then LED underscore OB dot value equals parentheses 1. I think that's going to do what I'm hoping it will do. Run the program, import the modules, set the variables, turn on the onboard LED, and then while true, if I press the button, you press the button, turn on the red light, turn off the green light, wait for 2 seconds, and then we're going to turn off the red light, turn on the green light. I think that's going to do it. All right, so I'm going to bring this over so we can see this happen. All right, so I hit stop. I'm going to hit run again. Green light came on, right? So my indicator light's on. Press the button, green light goes off, red light comes on, red light goes off, green light comes back on. Okay. So yeah, so that's an indicator light. So like this could be an alarm button, like somebody hit the alarm button. We can make, I mean, we're only using 2 seconds, but we could use it for 5 seconds. So that one thing we could think about doing, do they have I wonder if is there a blink function? So now we need to look at how do we look that up? Pico machine library documentation. Pin out, on, off value. So this one's going to blink an LED. Oh, they're making a definition of blink. I guess we could do that too. I would think they would have had a blink function.
So this is, right, so this is the quick reference. I'm in MicroPython. I'm trying to find for the RP2, so I think that's what we're looking for here. I was hoping that there would be like the pin, right? That pin would have a like a blink value. But what they've done here is they want to do, they're actually defining a blink value, a function, and they're going to call the function later on, right here. So they're creating that, which I don't want to mess with. That'd be way more than we need to get into today. Because
Hey,
my hope,
I am
yeah,
having a problem with my file being recognized by the system, right? It doesn't recognize it, and I'm getting like an error message regarding from the machine import pin. There is no module name machine.
so at the very top, right here, how's that typed? Is it typed exactly like that with the lowercase m and an
Right.
uppercase B?
Yeah, but I think the problem is, if you notice, yours is showing that, the program is running from the Raspberry and, the Pinko, right? Mine is not showing that. It's not showing the first line you have all the way at the top, where because it is not recognizing. Yeah, all the way
So
at the banner. Yeah.
what did you have in the bottom corner over here?
I just have Python.
So click on that.
All right, now it's giving me an option to go to the micro Python Raspberry Pi Pinko. Yep.
There you go. So click that, and then you should be good.
Okay, very
Then
good.
you should have it really similar to this. Sweet.
Okay, sound good. I'll keep
Okay,
working on that.
no worries.
Thank you.
All right. So my thinking here was I wanted to like maybe have this, we press the button and it does a little flashing sequence, right? So I was hoping that they had a blink and I could not mess with having to do it too much. But so what we could do here is, so we have it right now where, right, again, this is kind of getting into challenges, right? So and I'm a big fan of those kind of things, having the students do challenges versus just following the instructions, right? So then I press the button, the light comes on, then the light goes off and that goes off. What happens if I press the button, maybe I get this to flash like really fast for say 5 seconds, right? That's kind of what I want to try to figure out, right? So if we were to then maybe we could nest it, or we could just have it go through a value here. So like, so let's try this. Let's do for I in range. Let's do 0.65. And then, so LED value. So what we want to do first thing is we'll move LED underscore OB dot value 0. We're going to turn off the green light right away, right? So the green light turns off right away, and then we drop into, hopefully I get this right? We drop into a nested loop where we turn on the LED for, can we do 0.5s? We're going to try. Probably do 0.5. And then, oh no, that's not what I want to do. That needs to be on, right? So that's a 1. And then we need to sleep for 0.5, right? I love it. We got lights coming on all over the place. And then we need to turn LED dot value off, which is going to be 0. And then we're going to sleep for 0.5 again. Okay. So what I'm hoping this is going to happen here is so here's what I'm trying to do. I want to I want to turn on the unit or turn on the program, the green light comes on. If I press this button, I want the light to flash, I want the green light to turn off, and I want this to flash for 5 seconds, and then it should return back to normal status. Right? That's kind of the hope here. So let me hit stop here and see what happens, see if we get any kind of errors. Not yet. So hit this, right? So good, we got flashing. And then after 5, it should go back to normal. Good, okay, so, right, again, just another way to have the students kind of build, right, up their skills. In this case, we've added, and we have a while true loop with an if statement. And then we've nested a for loop inside of that to run the flashing lights. And we have now a LED, multiple LEDs controlled by a single button press, right? Creating basically an alarm, right? So somebody presses the button, the green light goes off, right? That status goes from green to red, and the red's flashing and all that kind of stuff. Yes, no, maybe so, kind of, sort of. Hope we're good.
Yeah, we're still typing. As I am.
Yeah, no worries. So I'm going to leave that on the screen there so you can play with that
I'm
one.
trying to find the other light that you have. It's
This
supposed
one?
to be. It's supposed to be in my kit, right there, right?
If you got one of the 3 kits listed, you should have had some LEDs in there. And a resistor, you need a resistor, LED, and a couple of wires.
Yeah, it says there's 10 resistors actually.
All right, yeah, so you need the 330s.
Yeah, 330R, right?
Yeah, 330 ohm, yep.
And then it have the push button. I have 3 of them.
Okay,
And then I have the 5 mm lid, and 2 of them, right? So that means I have those, right?
yeah, should happen.
Try that. It's all, like Chinese to me,
Yeah, to begin with, it always is. I mean, that's kind of the idea today, is just kind of play with it. And the more you kind of see it, and the more of these circuits that you get to work, right, just a better understanding, right? So that's kind of why we set this side, we set this day aside just to play with this particular device, right? It's all Python coding, which is what we use when we play with the Raspberry Pi, which is, I mean, that part of this, I'm really digging that part of this. And then I am going to, this is this MicroPython reference. This is going to be all the MicroPython, right? All the commands and everything that you can do. I'm going to go ahead and put that in our web page. I'll put that under the Pico stuff down below. Oh, and then all of the, it looks like I did all of the websites that I did earlier today that we talked about that were all Pico related. Those are all already there as well. So like all these websites that I keep hitting, I try to make sure that I put them over there for you. So we can kind of go back to them. Sweet. MicroPython documentation. I'm going to leave that on that screen because I think it's something we'll probably get to later. And then we verify these other ones are there. So pinout is there. I'm just kind of waiting for you guys, if you let you guys kind of finish those challenges, right? Because then at that point, we're done with chapter 4. We've got about a half an hour. Could probably pull off the traffic light. But I'm going to clean this up while you're finishing up your getting the circuits working. If you have questions, obviously on mic and ask or type in the chat. I'll keep an eye on those. All right, excellent. I like it when things work.
And can you put the second, like the diagram when you had, when you had the second light, the one on board that's working? So I found my lights right now. So
All right, awesome.
it can be plugged in right over there, right?
Yeah, so here's the official diagram. I can do that, or I can, right, we can just put this one here, which is how I have mine wired,
Okay.
whichever one you prefer.
Okay, my light is a little bit different. It just have 2 pins that you can, that you can.
Yeah,
just
so the
plug,
LED only has 2. There's a long leg and a short leg.
right?
So the long leg goes over here on this side with the resistor, and the short leg goes on this side that goes to the ground
The long go to the.
resistor. And so there's, in the material, in the book, it talks about LEDs, and LEDs are polarized, right? There's a plus and a minus side. So the electricity needs to flow a certain way for it to work. So which is why the diagram's always, like when you look at this diagram, there's a bent leg here. That's always going to be the long leg. And then the short leg will be the one that's not bent. Because the electricity, it needs to flow the right direction for it to work properly. The button, and
So
that,
the long one is going to be on the left-hand side.
yeah,
Where's the other one is?
right here. And then to the resistor, and the resistor to the pin 15. There we go. Get code and the official diagram and how I wired it. So all in the same picture.
Very good.
I'm thinking if you're at this point, like if you've gotten this working like I have it working here, like if you've done something along these lines to that challenge level,
and you're comfortable at that point, you can take off and have a longer lunch. If you haven't got to this point, keep on working. I'll hang out.
I just get the first one to work, the first initial one.
This first one up here, yeah. So now you're working
easy one.
on, yeah, so now you're working on the LED, like this LED, right?
Right, the second
Right
line
there.
to turn
There
on
we
as
go.
well.
Yep, we'll come back and do traffic lights and then keep on trucking. I kind of want to get to the LCD today. So we may jump forward just because. The LCD is different? That's not good. Did they provide you with a wiring diagram, hopefully?
Yeah, the
And-
wiring diagram is there, but they say the code changed it a little bit from
Okay.
from the bulb, and
Okay.
they point us to the GitHub, but I didn't see any.
Any change?
Yeah.
All right.
So, yeah, we'll see.
Well, yeah, we'll have to check it.
All right.
I'll start looking at that now. See if we can
Okay.
find it. Cool.
Thank you.
Thanks for the heads up.
Yeah, see you after the break. Okay.
Yeah, enjoy.
Yeah.
So right now I have my light on,
Yeah.
and I think mine comes with like it's like an like a button where it turns on and off. Smaller one, not like yours.
Yeah, those kits tend to have tiny ones. Let me, yeah.
Yeah, I'm trying to find the resistor right now. It is not showing up here. The resistor is kind of. Let's see, I have one. So those two cables have to be there, right? The ground one and the other one, right? They got to be there for the light to work, right?
Yeah, so the ground, like I do the ground, instead of doing like the way they've done it here, I just take a cable from here, number 3, and take it over here to the short leg, just a single cable.
Okay.
And then this cable needs to be here. And then your code, I'm gonna copy all of this real quick and just create a new one here. For this one, the code should look something like, okay, so in this one, we're not worried about buttons or anything. We just want this thing to turn on and off, right? So
Right.
something like this. I guess we could put this in a while true. So while true.
Right, so that code right there, if this is wired properly, this code right here will light this light up. And it'll go for, it'll turn on for half a second, off for half a second, on for half a second, off for half a second. It'll just keep on blinking.
It's the same as the first code. The only different, the first one is the pin is 25, right? And this
Yeah.
is 15.
And pin 25 is the onboard LED. And then 15 is because we're connecting to this pin right here to be pin 15.
Okay. So mine doesn't show like pin 15. I think that number is like 25, right? Or 20.
Oh, no. The down here, it's actually like the physical pin is 20, but we program to the green here. So we program to pin 15. So the very last pin is pin 15 from a programming standpoint. So you're going to plug into the very last pin, right? This last one here, which is for coding purposes, general purpose input output pin 15.
Okay.
Right? So yeah, so wired this way, programmed this way, that should come up.
Okay.
Should.
Let's give it a shot.
No worries. We'll get it to work. I'll be right back in about 2 minutes.
All right, how we doing?
Are there any questions?